automotive world is changing. We are right now in a transition towards becoming fully electrified. So cars and vehicles are becoming more quiet and products are becoming more complex.
We are facing this challenge as a compressor supplier because we are moving from a mechanical compressor to electrical compressor, and the integration into the cars is becoming more complex. As we had in the past, the cabin comfort as our priority. We have now to focus on the whole thermal management system, battery cooling, electronic cooling, and of course the combustion engine noise disappeared. The masking effect is gone, so the sound of the components are more dominant.
Which is one of the reasons why our customers are trying to identify different methods to ensure that suppliers like Sanden are developing the right product for the right vehicle.
To ensure this, it's important that we understand the requirement and customer understands our product. For that reason, it's important that we align with the customer on the right format of data exchange. And this is where we have the block force methodology as a key function to our product development.
In Sanden, we have different models of compressors. For example, some of them have 3 fixation points. Some others have 4 fixation points, and due to that, we need to change the receiver on which the compressor will be mounted. Before the block force methodology, all the NVH response we provided were dependent of the receiver. Now, thanks to the block force, we provide the information of the compressor only, completely independent from the bench. We are using Simcenter physical testing. Because we think that Siemens is very well advanced for the structure-borne noise determination, and in particular for the block force methodology.
Thanks to the block force methodology, we can provide to the customer some invariant load he can use to simulate the response of the compressor virtually. Thanks to the virtual instrumentation, we can define the position of the accelerometer and the heating point on the compressor. Then we can reduce the block force on only one point and then compare the block force from a compressor with 3 fixation points to a compressor with 4 fixation points. So we define the position of the measurement point and the hammer point, and according to the clearance around the hammer point, we can define to either use the hammer or the Q source, and we can do it in advance so we can be well prepared before the measurements.
With the block force methodology, we had 3 main objectives. One for customers, we want to provide the right information to the customer, but also for Sanden, we have 2 internal objectives. One is to compare all the data measured at different sites of Sanden worldwide, and also we want to be able to benchmark all the products we have, not only Sanden, but also competitors.
Besides the NVH requirements which we are facing together with the customer, there's of course another very important and significant aspect which we are together working on, which is the sustainability. The product needs to become smaller, it needs to become more lightweight, it needs to become more energy efficient. So together with Siemens, step by step, we are integrating the right measurement tools inside our processes to have a better product development for the future.
By using Simcenter physical testing, we have cut the development time by half. We have a product ready to be installed in the vehicle and to be tested, and we can confirm that there is no additional test efforts necessary because all the results were basically confirmed.